DeepSeek has recently shaken things up, not just in the AI industry, but also in the financial markets. Of course, it cannot be said that the project appeared out of nowhere, because DeepSeek was already known before. But it must be admitted that it shocked the world. It can be said that the people from DeepSeek challenged American dominance in the AI world and triggered a crash on the stock market in the United States, mainly a strong sell-off of Nvidia shares. In the meantime, a lot of rumors and controversies have emerged, but on this channel we talk about technical things. So today we will take a look at their latest model and write a program in Python using DeepSeek R1. So without further ado, let's begin. On the DeepSeek website, we have the opportunity to use the chat interface completely free of charge. It is probably not a big surprise that this interface is very similar to what we know from ChatGPT. Note that the DeepThink option is selected, which activates the R1 model, their latest reasoning model. To show you how it works, I'm asking a question related to the future of subbases. As you can see, the response is quite fast. However, note that this gray text is the chain of thought, something that is hidden in the case of O1. Here we can see clearly. So we have a chain of internal reflections here, which of course is sometimes good to read in order to know how the model reasons, but the real answer starts from this black text. It must be admitted that the response is not bad, maybe not perfect, but the model's knowledge is up to date. Interestingly, earnings are given in dollars rather than yen, which says something about the data the model was trained on. I see that rise with SAP is even mentioned. But this video is not for testing the model or using the chat. It's to write a program. That's why I'm moving to the developer console by clicking API platform link. As you can see, I am already logged in. A Gmail was enough for this. I also have my account topped up with $2. It can be done easily using PayPal. It may seem that $2 is very little when we look at the prices of reasoning models. But DeepSeek is cheap. Although there is a catch. Let's look at the price list. Only 2 models are available. DeepSeek Chat, known as V3, which is notably cheaper than GPT-4o Mini, with an ongoing promotion, and DeepSeek Reasoner, the new R1 model, which is 100 times cheaper for input tokens compared to OpenAI's O1 model, and 30 times cheaper for output tokens. However, it is important to note that chain of thoughts is included in the output tokens, which should definitely be taken into consideration, and will have a significant impact on short answers. It might also be worth knowing how token usage is calculated, as it looks somewhat different than in other models. Fortunately, if someone wants to know the precise details, a tokenizer is available. What interests me the most is how to use the API and how to write the first program. DeepSeek chose a rather clever method of adapting to its competitor standard, so we can use the API exactly as in OpenAI, except that not all functions are implemented. The base URL is obviously different because we are referring to DeepSeek servers. Of course, this documentation also includes examples in various programming languages. I am most interested in Python. As you can see from the example for DeepSeek Chat, the OpenAI library is directly used. But let's see what's hidden under the DeepSeek Reasoner documentation. You will find all the necessary information here, including the fact that the reasoning effort has not yet been implemented, but will be soon, allowing you to control the thinking process and at the same time the cost of reasoning tokens. Here is also a list of parameters that are not yet supported in this model, and as you can see, it is quite long. For many people, it is probably most important that function calling is not available, which somewhat limits the applications of this model. An example of use in Python is similar to DeepSeek Chat, also using the OpenAI library. However, the difference is that it also allows you to retrieve reasoning content if someone needs it, which, to be honest, is an advantage over O1, where this part is hidden. Of course, examples are not everything. We can also view the full API documentation as well as the API guides. I'm particularly interested in the chat, because we will use it with both DeepSeek Chat and DeepSeek Reasoner. But enough about documentation, as everyone can read it themselves. Let's move on to practice. First, I will generate an API key that will authenticate my user. The name doesn't matter here, it's just for you to distinguish applications. I will copy the key to the clipboard, but it's important for you to remember that it's a secret string of characters and you can't show it to anyone. At the time of publishing this video, my key is already invalid. But now it's really time to get serious about programming. I'll start by creating a virtual environment for Python. I've shown several times how to use venv, so now I'll just create the environment. And if you want to know the details, check out the previous videos. The name of my environment is DeepSeek Test. The system has created a directory and its contents. Thanks to this, I can activate the environment using the activate script. This is not needed here since I am about to move to Visual Studio Code, but it's worth knowing how to do it. I use Visual Studio Code because it's a very popular and great editor, and additionally free. I'm opening the folder I just created in my editor. There are already subdirectories created by venvironment. In the last video, I explained why keeping API keys and other secrets as environment variables is a good practice. Therefore, the first step will be to create a .env file. I'll place the API key there, which I currently have in my clipboard. I will name environmental variable DeepSeek_API_key. Having the API key, I can proceed to write the actual program. The first program will be based on pure libraries from OpenAI, and in the next step, we will deal with the LangChain, just like before. So I'm creating a file deepseektest1.py. Now I can activate my virtual environment in the way I showed earlier. However, this time I will use the Visual Studio Code terminal instead of PowerShell. I do have a plugin installed that did it automatically, as you can see from this message, but it's worth showing how to do it manually. The environment has been activated, but for some reason Visual Studio Code is still asking to choose an interpreter. I will do it. Now everything is definitely fine. I will enlarge the font so that it is clearly visible in the video, especially since some people watch these videos on mobile devices. Let's start the program with imports. I will definitely need OS to read environment variables. I will definitely need load.env as well, because that's how I'll read those variables from the file. But I must first install the appropriate module. This can be done using the pip install command followed by the module name. I can do it directly from the terminal in my editor. Then the appropriate files will be installed in the virtual environment. As you can see, the name for .env is already highlighted, so the editor recognized the installed package. I still need OpenAI. This was also visible in the sample code on the DeepSeek website. Since the terminal is still open, I will easily issue the command pip install OpenAI. This installation will take a bit more time because there are more dependencies and the package itself is also larger. The package name has been highlighted, so I can now finalize import OpenAI. And these are probably all the necessary dependencies. In the first step, I will load the environment variables using load.env. Now we need to define the OpenAI client. The constructor requires an API key, which I will retrieve from the environment variables. You probably remember that my variable is called DeepSeek_API_key, because that's how I defined it in the .env file. I will also need the base URL, because we are referring to servers other than OpenAI, specifically DeepSeek. Since I do not remember this URL, I will have to check the documentation on the DeepSeek website. But first I will define an environment variable DeepSeek base URL, because I will also store the URL here for convenience. Of course, I should have written it down earlier then. Now I wouldn't have a problem with it, but sometimes you forget about such things, which is quite normal. But that's not a problem, because I already found the DeepSeek site. I'm going through the documentation and I have the URL here. I've copied the URL to the clipboard, so now I just need to paste it in my .env file. Now I can return to my program and retrieve this environment variable as the base URL. Already during the video about a Python program using the Groq API, I mentioned that a conversation with AI involves sending a message history. In this case, it's the simplest message created by the user, containing a question. So I create a list containing only one element, which is a dictionary. I assign the user to the role, and I will enter my question in the content. In this way, my message history contains exactly one message. I need to come up with a question. I'll ask which of the numbers is bigger, because until recently, large language models often struggled with comparing fractions. To avoid a lengthy explanation, I'll ask about an answer in one sentence. Now, to obtain a response, according to the OpenAI documentation, I need to create chat completions in the client. This requires defining two things. First, a model, which will initially be DeepSeek chat, and a message history. The message history has already been defined by me. If you watch the episode about programming with Groq, you know that the response is a complex object. To fetch the entire content of the response, I only need a part of this object, specifically the first element of the choices list, message, and content. The last thing to do for the program to make any sense is to print the content. It's just a simple print command. I will move the code up so that the whole thing is visible and I can run it. As you can see, it is neither very long nor complicated. Let's run it. The answer didn't take long. It is, of course, correct. In fact, models from the DeepSeek family do quite well with mathematics. Alright, but that was the DeepSeek chat model, which is the older version without reasoning capabilities. Now it's time to focus on the R1 model, which has caused quite a stir recently. The change to the program won't be significant. Just change the model's name and everything should work. It should, of course, be expected that the response will take longer, because even though I ask for an answer in one sentence, reasoning tokens are also being generated. It simply takes quite a bit of time, and even for such a simple question, the thought process is lengthy. I expect the answer to be correct, but I'm curious if it will differ in any way from the smaller model. Yes, we have the response. And even as one sentence, the explanation is very logical from a mathematical point of view. The answer is fully accepted. I can add one thing to the program. At the moment, we cannot see the thought chain, while in the R1 model it is fully available. Admittedly, in the long run, in the final solution, we probably don't need it, because it is only supposed to make the model work better, but sometimes, especially when debugging or trying to understand how the model works, access to thoughts would be beneficial. In this case, it is not a problem. We simply extract reasoning content from the same data structure. I will also add printing of this content with 2 blank lines before the main text. And these are all the necessary changes. Now I can simply run the program. Of course, you might wonder whether I should be asking some more challenging questions to artificial intelligence in this video. But I would rather focus on how to write programs than on testing this model. You will certainly find plenty of tests, and I might conduct some myself on another occasion. Okay, the program has finished running and we have the response. The final answer is on the last line at the very end. And I must say, from a mathematical point of view, this explanation is quite convoluted. Although, of course, the answer itself is correct. It's somewhat strange, I don't really like it though. What I wanted to show, however, is the chain of thoughts that we can analyze to see how DeepSeek R1 arrived at this answer. And I think that this reasoning can say a lot about this a little strange answer. But as I said at the beginning, recording the chain of thoughts doesn't have much practical application in programs, or at least it doesn't come to mind at the moment. Perhaps in certain cases, this text can be recorded for later analysis. But in reality, we are only interested in the final result, not how the model arrived at it. unless we have some exceptional use where we want to subject this chain of thoughts to further processing. But let's leave these considerations for now. I mentioned that we will also write a program using LangChain. It does not directly support DeepSeek, but you can of course simply use the OpenAI API. I'll copy the first few lines of code, because I will use them in the next program. Let's call it the new file DeepSeek Test 2. I know, it's not particularly groundbreaking, but practical. I am pasting the copied 4 lines, but I need to remove import OpenAI because it won't be explicitly necessary. Instead, I will use LangChain. Specifically LangChain OpenAI, but since this package is not installed, I need to use the pip install command in the terminal again to install it. Note that the underscore in the names changes to a hyphen. The installation is in progress. It will take a moment, because this is not the most powerful computer. It's a mini PC for $100, which you can see in one of my recent videos on this channel. By the way, consider giving a like and subscribing if you like the video so far. That way, you won't miss future ones. In fact, this will be the simplest possible example, so I don't need to import too much. Just base chat OpenAI. If you want to see something more elegant, I invite you to watch the video about the first AI program in Python. That program is also simple, but additionally includes a string output parser and message templates. Here, I will initiate base chat OpenAI as LLM, for which I need several mandatory parameters. First of all, the model name, in this case, DeepSeek Reasoner. As you can probably guess, the API key will also be a required parameter here. As usual, I retrieve it from environment variables because it is defined in the .env file, and the variables are initialized by load.env, which is visible above. Since this is DeepSeek, not OpenAI, I still need to define the base URL. Without this, references will be to OpenAI, not to DeepSeek servers. I am retrieving it from the environment variables. What is not mandatory, but just in case I'll define it, is the maximum number of tokens. Although I don't expect to exceed anything here, it's good to know that this option exists, and the number of tokens can sometimes be problematic when sending prompts. To get a response, I just need to call the invoke method on my LLM object. It's all thanks to the simplicity of LangChain. Of course, I must provide my prompt as well, but this time I will ask about something at least a little more interesting and request a comparison of 2 transactions. The last thing I must do is write out the answer. This time I am writing out the entire object I receive, so there will be a bit more than just the text of the answer. Something went wrong. I got an authorization error related to an invalid API key. Okay, I see it now. This is the wrong URL for the API. I think I might have messed something up with the URL, and the default one from OpenAI was used. Here might be the problem. This variable is called DeepSeek base URL. Here I use the DeepSeek API URL, which is obviously wrong, so I need to change it to base. I'll try to run the program again, and we'll see if it connects to the right server this time. Just take into account that in such a case, in a more serious system, it would be necessary to invalidate the keys. You can see that I sent the API key to the wrong server, so potentially someone could use it, and it is a security incident. In my case, however, I won't worry about it because I only have $2 in the account. In a few minutes, I'll finish the experiment and will be canceling the key anyway. I have the impression that this time the response is taking a bit longer. It could be server overload, which is clearly happening recently due to the popularity of DeepSeek, or maybe this response just requires more thought. We already have the response. It is the whole object. Therefore, it is not very readable. That's why, in the episode with Groq, I used a string output parser to get plain text. However, here, you can read additional things, such as the number of different types of tokens used. This is where the actual content of the response begins. And as you can see, DeepSeek R1 correctly inferred that it was about SAP transactions and compared them appropriately. On the other hand, if we look at the contents of this object, we will easily notice that 649 reasoning tokens were used for the response, which are included in our total cost. Meanwhile, there were a total of 1,120 output tokens. And that's basically all there is to writing programs for DeepSeek. If you want to do an exercise on your own, I suggest you first try using the string output parser and message templates in this program, as we did in the Groq episode. This will help you better learn the absolute basics of LangChain. If you haven't watched that episode yet, I highly recommend it, because I explain the basics there, and additionally, Groq is a platform that will allow you to write programs using AI without any costs. Anyway, I would also like to show you something on the Groq platform, so let's go to their site for a moment. You may have heard about various versions of DeepSeek R1, and one of them is available for free on the Groq platform. You are probably familiar with this developer console because we used it in the episode about Groq, where I used Llama for free. As you can see, DeepSeek R1, 70 billion parameters, is also available for selection here. This is good news, because you can actually use it for free. Just be aware that it's not exactly the same. Yes, this model comes from DeepSeek, but it is essentially a llama trained by DeepSeek R1 to behave like DeepSeek. So the larger model passes its knowledge to the smaller one in a very clever distillation process. There is also another difference that I will show by typing the question we used previously. As is the case with Groq, the response is swift. And by the way, I noticed that I made a mistake in the question, but that's okay. We'll see how it handles the answer. The difference I wanted to show you is that in this case, chain of thoughts is simply closed by the think markers, meaning it is part of the main response. Alright, we have some hallucinations here due to my mistake in the question, but that's not that important. I just wanted to show that a certain version of DeepSeek is available here as well. Alright, a few more words of summary. Is DeepSeek R1 really such a revolution? Yes and no. It is certainly commendable that it is open source and indeed rivals O1 in many respects. However, let's consider a few facts. Firstly, this video is delayed by 2 days because for 2 days it was impossible to generate responses with this model as it was simply overloaded. It's probably a matter of it becoming a victim of its own popularity. Moreover, it should be noted that it is not a multimodal model and cannot accommodate all the features offered by OpenAI. But of course, let's also keep in mind this is not the last word of DeepSeek company. It should also be kept in mind that this is a Chinese model, which means it is quite heavily censored, or in other words, it has specific gaps in memory. Also remember that by using the official API, you are sending data to Chinese servers. So you could say that it is somewhat like the TikTok of the AI world. Nevertheless, it seems to me that such a model and awakening were needed for American companies. Hats off to the creators of DeepSeek. May you never lose money on Nvidia stocks bought at the wrong time. See you next time.